Today, we'll be talking about what you need to know about derivatives for our class in physics, and how much calculus you need to know when going into this class. So, a derivative from the graphical perspective, you should see it as the slope of the tangent line to a graph at a specific point. As we can see here, our derivative is the slope of this tangent line, which just grazes the point that we're looking at. It doesn't matter what the heck it's doing over here. It might cross the line over there, but once again, we're just looking over there. Just looking at that little bit. Now, the derivative is the instantaneous rate of change. Now, it's symbolized by dy by dx, df by dx, d by dx, f, or f prime of x for the function y equals f of x. Now, you can just read that as the derivative of f with respect to x, or any of the ways I said it, because those are faster. Now, the reason why the dy by dx, you might look at that, is what it means is you're looking at what happens to y, the y value of a function, when you change x a tiny bit. Now, you can take the derivative any repeated number of times, and it's notated by any one of the following. Or you could just say the nth derivative of f with respect to x. Now, with the second derivative as an example, you can write this as d2y by dx squared, or d by dx of dy by dx, or f prime prime, or f double prime. Or just the second derivative of f with respect to x, although that's a bit of a mouthful to say. Now, when you look at the derivative, you should see it as a function, and it can be evaluated at a given point, and it is written by dy by dx evaluated at x equals a, where evaluated at x equals a is given by this big line, and then x equals a. Or you could just write it as f prime of a, which really makes it look like it's a function, because the derivative is sort of a function. Now, derivatives aren't restricted to functions of x. It works for any variable name. Differentiation with respect to time is given by d by dt, or y dot and y double dot, where y dot is the first derivative and y double dot is the second derivative of y of t with respect to time. Now, in physics, you're often going to see the displacement function x of t, and the velocity function is just defined as d by dx, or dx by dt of x dot, or of, sorry, let me try that again. The velocity function is defined by dx by dt, or x dot. Now, similarly, the acceleration function is defined a of t equals dv by dt, v dot, d2x by dt squared, or x double dot. Any of those will work depending on what you're given at the time in your question. Now, our derivative rules, I'm going to explain a few of them and then let you look over the rest. So, the constant rule, this just tells us that the derivative of a constant is 0, which makes sense because when you look at a constant, it's not changing because it's a constant. It's called a constant for a reason, right? So a constant it just stays the same. And since it stays the same, there's obviously no change, so it's just going to be equal to 0. Now, the constant multiple rule is just when you multiply by a derivative, or when you multiply a function by a constant and take the derivative, it's the same as taking the derivative of the function and then multiplying by the constant. Now, your other rules are also good to know. These two can be a little weird because, like, why isn't it just the derivative of f of x times the derivative of g of x? It's really given by f of x times g prime of x plus g of x times f prime of x, and that comes from your formal definition of the derivative, which isn't important in the scope of this class. And then the quotient rule is even weirder. And the chain rule is probably the weirdest rule. When you look at a function of a function, otherwise known as a composite function, your derivative of it is equal to f prime of g of x, which is just like we're making g of x the input of f, our derivative of f prime, or derivative of f of x. So it's just like, oh, you have f prime of x? No, plug in g of x into the formula, and then multiply by g prime of x. Now, I prefer to write it as df by dg times dg by dx. Now, those look like fractions, and it looks like the two dg's cancel out, but the dg's and the df's and the dx's, they're what are called differentials, and in math, you cannot cancel out differentials. It can cause bad habits, and will make like can give weird answers later on when you get into more complicated calculus stuff. So even though it looks like this is just two fractions multiplied and you can just cancel out the dg's, you can't. Now, this is saying the exact same thing as this. You're taking the derivative of g, or of f with respect to g, and then multiplying by the derivative of g with respect to x. Now, here are some derivatives of specific functions. The most important ones to know are the exponential functions and the trig functions. Inverse trig functions aren't as important, but they're good to know just in case for some reason you need one. Now, we're going to do a few examples. Our first one, given the displacement function x of t equals t squared sine of t times the velocity function v of t, and find the velocity function v of t and the acceleration function a of t. Now here you're going to just use the product rule and the derivatives from the last section. Although I guess I should go back and let you look at that a little longer here. Now just pause and take a moment to look through them so you know what you're dealing with. So for this, take a moment, pause the video, and try to figure it out by yourself if you want to. Now for this one, for v of t, we're just taking the derivative of x of t. So using the product rule, it's the derivative of the first times the second, and then plus the second times the derivative of the first. So here we have d of t squared by dt times sine of t plus t squared d sine t of d over dt. So that, when we evaluate it, just gives us 2t sine t plus t squared cosine t, because derivative of t squared is 2t, derivative of sine is cosine. Now, to find the acceleration, we take the second derivative of x, which is just the same as taking the derivative of v. So we're going to do that. We use the sum rule and then the constant multiple rule, as you can see here. So we don't have to deal with anything crazy for the functions. And then we just use our product rule, derivative of the first times the second, plus the first times derivative of the second, and then we do it again over here. Doing some simplifications and noticing that derivative of t is just 1, the derivative of cosine is just negative sine, we end up with 2 sine of t plus 2t cos t plus 2t cos t minus t squared sine t is just equal to 2 sine of t times 4t cos t minus t squared sine t. Now we're going to look at a few chain rule examples, because as I said earlier it's probably the weirdest one. So here, find the velocity function given the displacement function sine of cosine of t. Give you a moment to pause and try it for yourself using the chain rule. Now for this one, we're going to define x in terms of f. So we're going to have x of f equals sine of f. This is just the outer function, and we're replacing cosine of t with just a new variable f because it's easier to deal with that way. And then we're going to make f a function of t and have it equal to cosine of t. So that when we put f of t as the input of x, or x of f of t, we get sine of cosine of x, because we're just taking this cosine of x and plugging it into this f for sine of f. So we have sine of cosine of t. Now when we take the derivative, we do x prime of f of t times f prime of t. Now, or x prime of f of t times f prime of t. So our derivative of x prime is just cosine of f, and now since we're plugging in f of t as our input, we have cosine of t times our derivative of f of t, which is just negative sine. So our answer is negative cosine of t times sine of t. Now this one, you're going to use the chain rule 3 times. Approach this one however you see fit if you decide to take the time to pause and figure this out. Now for this one, as I said, we're going to have to define, or we're going to use the chain rule twice. Now that means we have to define 3 functions. We're going to take f or x of f to be equal to sine of f. Then f of g equal to e to the g, and g of t equal to 2t. So that way, when we take the g of t and plug that into f of g, we have e to the 2t, which is just this inner bit. And then the inner bit, e to the 2t, we plug that into sine of f, so we have sine of e to the 2t. Now, we're going to do the chain rule twice, so we're using the chain rule once, dx by df, df by dg, and then we're saying, well, df by dg isn't in terms of what we want, so we're going to multiply it again, use the chain rule on this bit, which was the chain rule of the first thing, and just multiply it by dg by dt. Now, taking the derivative each with respect to its own variable, we have d by df of sine of f times d by dg of e to the g, and then d by dt of 2t. And now we just have cos f times e to the g times 2t, or times 2 by our derivative rules. Then we're going to plug in f for the first step, and f is just e to the g, so we have cosine e to the g times 2e to the g. Then we're going to plug in all of the g's with functions of t, so we have cosine e to the power of 2t times 2e to the power of 2t, or just making it look a little cleaner, 2e to the 2t cos e to the 2t. Now we're going to just do a collective example with a few of the rules put together. And take your time, pause the video, and figure it out for yourself if you so desire. For this one, I'm not going to talk through every step like the other ones. I'm just going to say what rule we're using where. So here, we're just going to take the sum rule and split it up into each function, each little component. And then we're going to take the power rule for d by dx of x to the fourth. Then we're going to use the chain rule, substituting x squared with u, so it looks nicer, like we did with the last 2 chain rule problems. Then we're going to use the product rule, and then d by dx of 7 is just 0, since it's a constant. Then just going out with what we've got 4x cubed times 2x cos u minus e to the x over x minus e to the x ln of x. Then substituting back x squared for u, you have 4x cubed plus 2x cos x squared minus e to the x over x minus e to the x ln x. And that's it for today. You just covered the basics of derivatives, what you need to know for calculus, or not calculus, for physics. And next week, or next video, we will be covering integrals. And thanks for watching. I'll see you in the next video.